All right, so this starter skill is called algebraic manipulation. Okay. During calculus, it's really important for you to know how to rewrite expressions and be flexible in using different forms depending on what's most useful to you in a given problem. And so a lot of times this means that you're going to need to know exponent rules. All right, and so we have some rules that hopefully you already know by heart, but we're just going to run through them again, right? So when you're multiplying like bases, you add the exponents. So I gave you the example like x to the 10th times x to the 4th. Since both bases are x, I'm multiplying them, I can add the exponents. If you're not sure why, think about this, right? X to the 10th is meaning x times itself 10 times, and here I'm multiplying 4 more x's, and so there'd be a total of 14 x's. Okay. When dividing like bases, you're going to subtract exponents and make sure that you're doing the top exponent minus the bottom exponent. I have a couple of examples just to make sure that this is clear. So again, same bases, right? Both bases are a. 8 to the 8th divided by 8 to the 5th. Well, 8 minus 5 gives me that same base a to the 3rd power. Okay. Sometimes you're going to see these exponent properties pop up when there's regular numbers in there too. And I know that you know this, but don't lose your mind, right? You're not going to treat regular numbers as if they're exponent numbers. And so like if I have 6y to the 4th over 3y to the 8th, I'm still going to do 6 divided by 3 like I normally would and get an answer of 2, right? But when I get over here and I notice I have the same base, I'm going to subtract those exponents. 4 minus 8 is that base to the negative 4th power. When you have an exponent to an exponent, you're going to multiply those exponents, right? So when you have something like x squared to the 5th, that's x to the 10th. Okay, don't forget that you need to make sure that if you have regular numbers, you're treating them the exact same. So if I have a bunch of stuff in parentheses, I'll do a power. Everything gets that power, right? So 4 times b to the 7th, all of that squared. That means I'm going to have 2 copies of 4, so 4 squared. And I can use the exponent rule we just talked about, and 7 times 2 is 14, and so my final answer could be 16b to the 14th. All right, you would get a different answer if the parentheses are in a different spot, right? So what would the answer be if the parentheses were moved over? Well, the only thing getting squared here is the b, and so this would be the same thing as 4b to the 14th. So it does make a difference where the parentheses are, all right, and I know that you'll be paying attention to that, okay? When both the numerator and the denominator have the same power, you can write it as a fraction to that power or vice versa, right? This is one of those things where flexibility can be important. So if I see I have x to the 3rd over x cubed, that's the same thing as the fraction 3 over x all cubed, right? Or sometimes it's helpful to go the other way. If I have a over b to the 5th, that's the same thing as a to the 5th over b to the 5th, okay? For the most part, we'll get to some examples when you learn something called L'Hopital's rule, but for the most part, something in the 0 power is 1. So this is kind of our classic, right? X to the 0 equals 1. If I have all of this disgusting stuff, but it's all to the 0 power, well, that equals 1. I do want you to make sure you're thinking about order of operations. Here's where parentheses are important. Right here, this says the quantity to x to the 0 power. Right, that's 1. But if I have 2x to the 0 power without the parentheses, right, that is a little bit different, and that would be 2 times 1, which is 2. So it does matter where the parentheses are, okay? These are not the only exponent rules, but these are the ones I feel like you really should know. The other two we will talk about in the next video because they are the most misused ones and probably really ones you're going to want to make sure you feel comfortable with in order to be successful in calculus.